For as long as humanity has existed, we've looked up at the stars, filled with wonder and curiosity. Those distant points of light have always beckoned, fueling our imagination and sparking the age-old question: are we alone in the universe? Throughout history, civilizations have crafted myths and stories about the stars, and astronomers have tried to map the heavens. But despite our deep desire to understand the cosmos, the vastness of space remained almost overwhelmingly mysterious. As we look beyond the confines of our world, the possibility of discovering other planets, planets like Earth, has become a tantalizing prospect. Could there be a place out there where conditions are just right for life to take root? A world where oceans ripple under the light of distant stars, where the air is breathable, and where life thrives in its many forms. This is the quest that drives modern astronomy, the search for exoplanets. An exoplanet is simply a planet that orbits a star outside our solar system. To many, these distant worlds were once merely speculative, the stuff of science fiction. But in recent decades, the line between fiction and reality has blurred, and our ability to detect and study these planets has rapidly advanced. Today, we know that planets are common in the universe. So common, in fact, that there may be more planets in our galaxy than stars. Some of these planets are gas giants, similar to Jupiter, swirling with storms and distant from the warmth of their stars. Others are hot, molten worlds, scorched by the radiation of their nearby suns. But then, there are those rare gems, planets that could potentially harbor life, just like Earth. These Earth-like planets exist in what we call the habitable zone, a region around a star where temperatures are just right, not too hot and not too cold, for liquid water to exist on the planet's surface. And water, as we know, is the essential ingredient for life as we understand it. Imagine a planet not too dissimilar from our own, a rocky, terrestrial world orbiting a star in the Goldilocks zone. Here, liquid water could flow freely, the oceans might sparkle under a pale blue sky, and an atmosphere could sustain life. Finding such a planet is one of the greatest challenges of modern science, and yet, with every discovery, we edge closer to a monumental breakthrough, an answer to one of the most profound questions humanity has ever asked. Is there life beyond Earth? To understand how we find these distant worlds, let's look at one of the most important tools in our cosmic exploration, the Kepler Space Telescope. Launched in 2009, Kepler revolutionized the way we study exoplanets. The mission's primary goal was simple: to survey a small section of the sky and look for Earth-like planets orbiting stars in the habitable zone. But finding a planet in the vast expanse of space is no easy task. These distant worlds are incredibly faint, often hidden by the overwhelming light of their parent stars. So, how do we detect them? The answer lies in one of the most brilliant techniques ever devised, the transit method. The transit method relies on something simple yet profound. When an exoplanet passes in front of its star, it causes a temporary dip in the star's brightness, like a brief shadow passing across the face of the sun. By carefully measuring these dimming events, astronomers can calculate the size of the planet, its orbital period, and its distance from the star. These measurements are crucial in determining whether a planet is in the habitable zone, where life-supporting conditions might exist. Kepler's discoveries have been nothing short of remarkable. By the time its mission ended in 2018, Kepler had identified more than 2,600 exoplanets. Some of these worlds are eerily similar to Earth, roughly the same size, located at the right distance from their star, and possibly possessing the right conditions for life. One of the most exciting discoveries was Kepler 452b, often called Earth's cousin. This planet orbits its star at a distance similar to Earth's orbit around the Sun and is located in the habitable zone. It's roughly the same size as Earth, and while we don't yet know if it has an atmosphere or liquid water, it remains one of the most promising candidates for future study. Kepler wasn't alone in its search. Another powerful technique used to find exoplanets is the radial velocity method, also known as the Doppler method. This technique takes advantage of the gravitational pull that planets exert on their stars. As a planet orbits, it causes the star to wobble ever so slightly. This wobble can be detected by measuring the shift in the star's light, much like the change in pitch you hear when a car passes by you honking its horn. Using this method, astronomers have detected many more exoplanets, especially large gas giants like Jupiter. But this method also provides critical information about the star-planet system, such as the planet's mass and orbit. While the Kepler mission has provided us with thousands of exoplanet candidates, the search is far from over. Enter the James Webb Space Telescope, launched in December 2021. Webb is designed to be the successor to Hubble, but with a twist. It can observe the universe in infrared light, allowing it to peer through dust clouds and study the atmospheres of distant exoplanets. What makes JWST so special is its ability to detect the chemical composition of exoplanet atmospheres. As light from a star passes through a planet's atmosphere, the gases absorb certain wavelengths of light, creating a unique fingerprint that scientists can analyze. This allows us to study whether a planet has the right mix of gases, like oxygen, methane, or carbon dioxide, that could indicate the presence of life. With its extraordinary capabilities, JWST will soon begin to provide us with crucial information about exoplanet atmospheres, their potential to support life, and their overall habitability. The hunt for Earth-like planets is entering a new chapter, one where we can move beyond just detecting planets and start studying their environments in detail. But the search for planets like Earth isn't just about finding planets that lie in the habitable zone. It's about understanding what makes Earth so unique in the first place. From its magnetic field, which shields us from harmful solar radiation, to its plate tectonics, which regulate the climate, Earth is a dynamic and complex system. For a planet to support life, it needs more than just water. It needs stability, protection, and the right conditions over millions of years. Finding other planets with these features is an ongoing challenge, but it's a challenge that scientists are determined to meet. As we look ahead, the next frontier in the search for Earth-like exoplanets is even more ambitious. The next generation of telescopes, like the Nancy Grace Roman Space Telescope and missions to study the atmospheres of exoplanets directly, will open up new avenues of exploration. And while we may not yet have the technology to send humans to distant stars, we are already planning the next great steps. Missions to study nearby exoplanets in greater detail, and perhaps one day, to send probes to explore them firsthand. With each discovery, we come closer to understanding our place in the universe, and whether we are truly alone. The search for Earth-like planets is more than just a scientific pursuit. It's a journey of exploration, wonder, and possibility. Who knows what lies out there, waiting to be discovered? As we continue our exploration of the stars, one thing is clear. The search for Earth-like exoplanets is one of the most exciting and profound quests of our time. Each discovery brings us closer to answering the greatest question of all: are we alone in the universe? And as we look to the future, we find that the universe itself is the greatest mystery of all, full of possibility, waiting to reveal its secrets.